So the purpose of this video is to make sure you folks understand how to solve a system of linear equations using inverse matrices. Now, I'm skipping over a lot of like what the heck's a matrix and what the math operations are involved with that. If you have to take a finite math course, or if you ever have to take a linear algebra course, you'll get well versed in that. I'm just trying to make your life easier when you're solving systems, okay? And if it's a 2x2 system, honestly, those are pretty easy. You can either use, substitution or linear combinations or graphing to do it. When you start in and get to larger matrices, it's a bit more of a pain. So in this OpenStax textbook I'm pointing you to for this last week, maybe next week too, 9.7 is what I'm looking at, and they go through a lot of ways how to find an inverse. I don't want you to do that. We're going to do this all with tech. But what's the theory behind? See how they do? What's the theory behind all this? Well, if we've got an equation. Well, let's talk about an easier equation. I mean, matrices are their own kind of algebra, matrix algebra, right? But the algebra we've learned for earlier math, what if I have 3x equals 5? Well, you learned back in 8th grade, 9th grade, in high school that you could divide both sides by 3 and solve that, right? So x equals 5 divided by 3. The other way that your teacher might have discussed this with you, I know I do, instead of dividing by 3, I might want to multiply by 1/3. And the reason I want to multiply by 1/3 is because 3 and 1/3 are multiplicative identities. When I multiply those, I get 1x, 1 being the multiplicative identity. You multiply anything by 1, you get, it doesn't change it, right? So multiplying a value by its multiplicative inverse gives us the multiplicative identity. That's a lot of work just to say I'm going to multiply by 1/3, okay? So, but we can do the same thing with matrix algebra. Now, let me clear this writing. No, I want to clear this writing. Clear all drawings. Here you go. So what I'm going to do is scroll down here until they come down to about solving a matrix equation. Okay. Here we'll do an easier one. We'll do this one, number 7. Okay. So what we need to do is we need to create. This is a system of linear equations, 2 variables, 2 unknowns. So what we're going to do is we're going to create a matrix equation. And what we do is you're going to break the equation out to the coefficients times the variables. The variable matrix equals the constant matrix. Okay, that's all we're going to do. So it's really easy. We're just going to take the coefficients of the values, 4 and 11, and we're going to slap that. It's an own matrix with rows and columns. Then we have x and y are our variables. That equals the constant matrix of 5, 7. And, with more time, with more energy, we'd see how to do that algebraically. But we don't have to. Now that we've got this broken out into a matrix, we're going to say this is matrix A. And we're going to say this is matrix B because it's our constants, okay? So what we're going to do, if you have a graphing calculator, a TI graphing calculator, I'm going to show you how to put that into it. Okay, if I can get my mouse to work here. Let's move it up. So the way you do this with your graphing calculator here, let me clear all the key press history too. So what you're going to do is, let me get a pointer going. You can see it. So see how the little blue matrix words are in blue there, and it's above the x to the negative 1 key? We're going to do second matrix, and it kicks up this matrix menu, and we want to edit. So what we do, we have to scroll over using the arrows to edit. I want to edit matrix 1. And this is a 2 rows, 2 columns. So 2, enter, 2, enter. And then we're going to type in the numbers, 3, enter, and it goes across. As you can see, it goes across. 4, enter, and then 11, enter. I can't tell you how many times I've messed up and not changed the dimensions, okay? So I'm going to quit this now. I quit this, go back to the home screen. And now we're going to create a matrix, a two row, one column matrix for the constants. So second matrix, come over to edit. Now here's the other mistake I've made many times. We want to not change matrix one. We're going to want to change matrix two. And this is 2 rows, 1 column. And then we're going to type in the 5 and the 7. Now we've got those 2 matrices in our calculator. Second quit. So now what we're going to do is we're going to do that. I mean, in the textbook, they talk about this, but remember how we want to multiply. I mean, if we had 3x equals 5, we multiply by 1/3. With matrix multiplication, order matters. It's not commutative. So we're going to take that multiplicative inverse and put it before the 5. So that's what we're going to do here. We're going to do A inverse times B. And that's how that raising a matrix to the -1 is how you find the multiplicative inverse. Okay, that's what we want to do. So, and to do that by hand, find the inverse by hand is a royal pain, I think. So what I'm going to do is I'm going to do second matrix 1. I don't want to edit it. I want matrix 1 now. So I'm just going to type a 1. Then I'm going to hit X to the -1 key. That's going to see how I did that. And then we do second matrix 2 because we got our other ones in 2. And it's given us the answers. X is -1, Y is +1. So that tells me that these 2 lines cross at the point -1, 1. So it's always good to write it back as an ordered pair. Okay. So that's a 2x2 matrix. Maybe we should look at a 3x3 matrix. I'm in the textbook or in that OpenStax textbook. And when we have 2 variables, we need 2 equations to solve them. When we have 3 variables, we need 3 equations to solve them. Okay, but it's the same math. Now, what's weird, let's look at number 36, or we can even do number 37 since we probably have the answers. Okay, so what we're going to do is we're going to pull those coefficients. Notice how it has an x and y and a z in each of those equations. So 6, -5, -1, and then -1, +2, +1. See, I'm just pulling the numbers, the coefficients right off those. And then 3, 3, 2. So there's my coefficient matrix. Now we need our variable matrix, x, y, z. And that equals the constant matrix of 31, -6, 13. Now, if, 31, my famous trick is I'll mix up problems. Good, I got that. Okay, so now to do that, to solve that system of 3 equations with 3 variables takes me a page and a half of work because you got to pick 2 of the equations, get rid of, like if I were to do this by hand, I would equation 1 and 2, add those together to get rid of the z's. And then I'd probably pick equation 1 and 3 because I haven't used 3 yet, multiply equation 1 by 2, add those together. You have another equation with just x's and y's. So then you get a 2 by 2, solve that, go back and find z. Pain in the butt. But this is pretty easy. So if we were going to do this with your matrix, with a calculator, if you have a graphing calculator, I want to try that, go ahead. Always, I'm just going to continue, but if you want to try it yourself, if you can do it. So second matrix, here, let me get a pointer going so you can see what I'm doing. And we're going to edit matrix 1, because we don't need that old matrix 1. And this is a 3 rows, 3 columns. And we're going to do 6. And just what you want to watch is watch me typing in things on a keyboard, huh? Enter, and then -1. If I make a mistake with this, if I don't ever get the answer, I mean, it's because I typed something in wrong. If it's been a while since you used your graphic calculator, because everybody uses Desmos now, remember that's how you do a negative number. That's a subtraction. -1, 2, 1, then 3, enter, 3, enter, 2, enter. Okay, now I've got, let me double check, make sure I've got everything typed in right. Well, I don't see an error. I'm going to quit this. Second matrix, edit, make sure we're going to do number 2. You can either come down or type 2. Okay, and this is a 3x1 now, 3 rows, 1 column. Do the 31, -6, then 13, or 31, 6. Okay, so I'll quit this. And then I'll do, I mean, you probably know all the shortcuts. I could go up and grab that, but I'll walk you through it by hand. So we're going to do second matrix 1, hit x to the -1. Then we do second matrix 2, and we get 5, 0. So we do have an ordered pair here. We have an ordered pair of 5, 0, -1. Actually, not an ordered pair, it's an ordered triple. Okay. Just out of curiosity, let's go back to the OpenStax and let's see if it'll jump up, show us the answers. System 9.7, right? Section, what exercises? Yeah, I don't know. I kind of like what they're doing with this in this textbook, but I don't remember what number this was. Was it 13? No, it could be 13. Here's the one. Must have been number 37. There it agreed to my answer. Okay. Now, the only other thing I should show you before I leave here and go back and do something else. Here we go. What happens with a matrix? Clear all lines. What happens when you have equations that are missing variables? I have 3 equations. Where is one? Here we go. Like something like, well, something like 39. You'll see something like that in my open math. So what you do for your matrix, coefficient matrix, well, equation 1's the same, 4, -2, and 3, nothing new there. The same thing for equation 2, 2, 2, -9. But then we don't have an x here, so we'll put a 0, 6, -4. Okay, and then you can do the rest, then put your variable matrix and your X, Y, Z. On the exam or on the quiz, one of the quizzes you're going to be asked for next week's quiz, I believe. I'm going to ask you to solve like a 4x4 or 5x5 system. Pretty miserable. I'm trying to make you do the matrix, right? But I ask you to write the matrix equation. This is what I want you to do. What am I doing? So that would be -12, 33, and 1. And then you can just use a calculator or use that other, that Math is Fun matrix calculator that says what this next video that I have posted shows you how to do if you don't have a TI grapher. Okay, so that, I guess that's solving systems using inverse matrices. It's really slick. The MyOpen Math assignment has some mixture problems on it. Create the problem, create the system with the X's and Y's and Z's or write the matrix equation to solve it. No sense in doing all that work. Okay? Well, hopefully this helps you use your graphic calculator.